We're going to talk now about solving equations with variables on both sides of the equal sign. Let's look at the equation 5x plus 2 is equal to 2x plus 14. This really isn't different than solving multi-step equations. We're going to use inverse operations still, and we're going to try to get like things combined, in like terms combined. So let's look at this equation initially. And one of the things I like to do is I like to limit the number of times I have to deal with negative coefficients. And our coefficients here are 5x and 2x, and they're both positive. So I'm going to have to subtract them from one side or the other. Now, if I subtract 5x from both sides, I'm going to end up with a negative 3x over here. So instead of doing that, I'm going to go ahead and subtract 2x from both sides, leaving me with 3x on the one side plus 2, and just 14 on the other side, because those cancel out. So now what do? Well, I continue solving. I'm going to subtract 2 from both sides here, and that's going to leave me with 3x equals 12, and now we're down to our one step. Divide by 3, x equals 4. There are other ways you could solve this equation. Again, we could have subtracted 5x from both sides, subtracted 14, gone through the same process. If we do it right, the answer will always come out the same as x equals 4. The problem is there are ways of doing the problem that will allow for more errors. So avoiding as many traps as possible is really the way to approach it. And that's why I avoid the negative exponents, so that I don't get too confused with signs as I go forward. We're going to go ahead and add another level of complexity to this by adding some grouping symbols. So we're going to look at 2 times 5x minus 1, close parentheses, equals 3, open parentheses, x plus 11. The first thing you want to do here is get rid of the parentheses. And the parentheses are really there because you're saying that it's 2 times 5x, the whole expression 5x minus 1, and 3 times the whole expression x plus 11. So to get rid of them, we have to use distributive property. So we're going to distribute the 2 to every term inside these parentheses and distribute the 3 to every term inside these parentheses. And what's that going to look like? Well, that's going to look like 2 times 5x is 10x. 2 times negative 1 is negative 2. We don't need parentheses anymore because we've done our distributive property. 3 times x is 3x. And 3 times 11 is 33. So now I could move forward and subtract 10x from both sides, but that's going to leave me with a negative 7x, and I don't like the negative coefficients. So instead I'm going to subtract 3x from both sides. And I'm subtracting the 3x from the 10x and not the 2 because 3x and 10x are like terms. 3x and 2 are not. That leaves me with 7x minus 2 equals, the 3x's cancel out here, 33. I'm going to go ahead and add 2 to both sides, and I have 7x equals 35. I've run out of room, so let me just clean this up a little bit. So we've gotten to the point now where we have 7x equals 35. Okay. Divide both sides by 7. X equals 5. And if I plug that back in, I find that, yes, in fact, that does work out. So that's how you solve it when you have grouping symbols and you have to deal with variables on both sides of the equation.